Hi friends, welcome to Jitesh classes. This is new topic in physics, fluid statics. This is related to JEE. In fluid statics, when we take the word fluid in physics, we will have two sections in that. Those are hydrostatics. The word fluid and hydro mean the same, so we can take hydro or fluid. We can say hydrostatics or fluid statics. And another one is hydromechanics, hydrostatics and hydrodynamics. In hydrostatics means the study of fluids in rest, and hydrodynamics means the study of fluids in motion. In today's session, I'll explain density, relative density, specific gravity, and in density I'll explain those terms, kg, meter, cubes, those units I'll explain. And after specific gravity, pressure in fluids, and next gauge pressure. Cut. Fluids means liquids and gases are fluids. They are called fluids. Density. There are volumetric density. Volumetric density means mass by volume. Means the certain mass per certain volume. That is called density. If we take a point density, means if in a jar we are taking liquid, in this point, this is the volume of this total liquid in the jar is V. For this part the volume is dV, and the mass of this one is dm. So we can say rho is equals to dm by dV. This is point density. In a fluid, a point density is defined as dm by dV. dm is a mass for certain part, means m is the whole mass of the whole liquid, and the dm is the mass of the small part, which we can take that point part, and the v is the volume of total liquid, and dv is the volume of that small part which we are taking. So dm by dv is equals to point density. And in case of homogeneous isotropic substance, it means that homogeneous are made up of same parts, same elements or same thing. And isotropic means no variation of magnitude in any direction. That is homogeneous isotropic substance. It has no directional properties, so it is scalar. The density, it has no directional properties, so it will act everywhere, but it don't have direction. It won't act in a particular direction, so it is scalar. The dimension of density is m power 1 L power minus 3 T power 0. That is dimension, and SI unit is kg meter cube, and CGS unit is centimeter cube. Now I will say the units of measurement of volume. Volume, unit of measurement, okay. 1 unit is measured with meter cube or centimeter cube. 1 meter cube is equals to 10 power 6 centimeter cube, and 1 centimeter cube is equals to 10 power minus 6 meter cube. and 1 liter is equals to 1000 centimeter cube or 1000 cc, and 1 meter cube is equals to 10 power 3 into 10 power 3 centimeter cube. So 1 meter cube is equals to, see, 10 power 3 centimeter cube is equals to 1 liter. So 10 power 6 centimeter cube is equals to 1000 liters. Density. Now density units. Density is measured in kg per meter cube or gram per centimeter cube. So 1 gram per centimeter cube is equals to 10 power 3 kg per 10 power minus 3 kg per centimeter cube. So 1 centimeter cube is equals to 10 power minus 6 meter cube. We need kg per meter cube. So we will convert this into kg per meter cube. So we need kg per meter cube. So 1 kg per meter cube is equals to 10 power minus 3 kg per 10 power minus 6 meter cube. So this will go up. Then what will happen? 10 power minus 3 into 10 power 6 kg per meter cube. So 10 power 3 kg per meter cube. 1 gram per centimeter cube is equals to 10 power 3 kg per meter cube. Now relative density. Relative density means the density of the substance by density of the reference substance. It means that if we take two liquids, one is Hg, mercury, and another one is water, H2O. If water is watching mercury, then the density of mercury with respect to water, it will be that density of mercury by density of liquid, density of water. It means that rho A per B, A is a liquid and B is a liquid. Rho density with for A of A with respect to B means is equals to density of A by density of B. Means density of a liquid with respect to the reference substance is equals to density of the liquid by density of the reference substance. That a small example on that relative density topic. Density rho mercury, density of mercury is 13.6 into 10 to the power of 3 kg per meter cube, and density of water is equals to 10 to the power of 3 kg per meter cube. And the question is density of mercury with respect to density of water. It's equals to, now we know the formula, that is relative density of a liquid with respect to reference substance is equals to density of the liquid by reference liquid, by density of reference liquid. We can take that this is the liquid and this is the reference liquid, because he said that density of mercury with respect to H2O, with respect to water. It means that water is reference substance and mercury is the substance which was being watched. 13.6 into 10 to the power of 3 by 10 power of 3 kg meter cube, and this one is 13.6 is the relative density. Correct. Now the topic is specific gravity. It means that density of a liquid with respect to density of H2O, and it is also can be said in the words of relative density, that density of a substance and the reference substance as water, liquid, means the in relative density, specific gravity is also can be seen in relative density, that density of a liquid is the substance and the reference substance will be water, that's it. This is specific gravity. In specific gravity Sg of a something is equals to rho of A, means specific gravity of A, we'll take a substance A, liquid substance A, is equals to density of A and by density of H2O, water. For if we want density of A is equals to density of H2O into that specific gravity of A, that's it. Now starting the main topic, fluid statics. Main topics, that fluids, this is the correct definition of fluids: substances which do not have definite shape, that means if we move a liquid, this is a liquid, this is a jar containing liquid or water. If we take an example, water, a liquid water, if we move this side, it will change its shape, and if we'll fill water in a bottle, it will change its shape. So it doesn't have a definite shape but have definite volume, means it will be volume per unit. It will have, if we take certain area, a certain volume of water, it will be that it won't change. If we'll take some water outside, then only it will change, but if we move it, the water does not change. That is called fluids. Almost constant density. They have almost, fluids have almost constant density. Certain fluid, if we remove some water out of it also, it has same density. Density won't change. That's it. Now, interface. Interface is a fluid separated by an interface from solids and gases. Means that we'll take a glass. This is a glass and liquid inside it. This is air. Now this liquid is touching this solid, this glass. It means that this is a solid interface of the liquid, and this is an interface, and this is an interface, and this is an interface. Air is the interface. Free interface means air that's full of freedom, and it is free interface. Air is the free interface, means there is a point that the fluid interface bounded by a gas is called the free surface of the fluid. It means that air is the free interface of a liquid. In any liquid, air is the free interface. Air is the free interface, and the interface means for which the liquid is touching. Here it is touching the glass. So the glass is the interface, solid interface of the liquid. Interface. This is the interface topic. Now, pressure in fluids. When an external pressure in fluids, it means that when an external force is applied on a fluid body, it internally gets disturbed, and that is called pressure. It develops an internally disturbed pressure at all points of the fluid body. The pressure is fluid pressure. It means that a glass, it's a glass. In that, it's water. When an external force is applied on a fluid body, the external force is here for every molecule, mg is acting downwards. If in a freely falling body, it doesn't exert pressure. It means that if we take a man is here, on him, see, a man is here, on him, if he kept a mass of mass m, and another mass of mass m. If he take on 5 masses, he will exert pressure when he is at rest. If he is freely falling, then he does not exert pressure. Means if he is carrying like this, if he is freely falling from a building, if he is falling, he doesn't exert pressure. He doesn't exert the mg on him. When he is at rest, he will exert the pressure. Similarly, in fluids, if they are at rest, they will exert pressure. At the bottom, the pressure, full pressure will be at the bottom, and those all will exert, that liquid will exert the pressure. When it is freely falling, like if we take a glass it is freely falling, then it does not exert pressure. That glass or the liquid does not exert pressure. So we can conclude that from here the liquids exert pressure when they are at rest, and it develops an internally disturbed pressure. When it is at rest, they'll develop an internally disturbed pressure. That's the pressure of fluid pressure. See, if we take a molecule from a H2O molecule from the water that is surrounded with some molecules, the molecules will be binded. That is surrounded with some molecules. This will exert some normal pressure. This will exert. This will exert. This will all will exert. Those all will exert in this middle one will apply the pressure in equal quantities on every body. In these 5 bodies, on 5 molecules, it will exert the equal pressure, this molecule, and this exerts some pressure. Means this all will exert the pressure and it will get disturbed. Similarly, for this also, it will be surrounded with some molecules like that. Every molecule will be exerting some pressure and applying some pressure on the other molecules. So it is getting disturbed, and it will get disturbed at rest. That pressure will be applied. So if we take a liquid, a glass, if it is exerting pressure in this direction, the water, if we take a glass, it is exerting pressure in this direction, then if we will turn into this will exert pressure in this direction. So it will move, it will come, this water will come like this. If we will exert some more, if we will turn some more, it will exert more pressure this side. So the water is falling. It will exert more pressure on this, and it will still move on this side.
Start.
Now gauge pressure. We will take a gauge like this, and in this liquid of density rho, and the liquid is up to a height h, and this is the bottom, and we will take the area of the bottom, because the whole total pressure of this total liquid, the total pressure is exerted downwards, because every molecule mg all are acting downwards. Total pressure will be more at the bottom, and total pressure is acting downwards. So it will be at A, at this bottom. So that area of that bottom is A. We will take for deriving gauge pressure formula, and the pressure, fluid pressure, the pressure units are Newton per meter square, and F is equals to mg, and m is equals to rho v, density into volume. So density into volume into rho vg. V is equals to area into height, area of this bottom into this height. F is equals to rho ah into z. This A will transfer this A this side. Then we will get F by A is equals to h rho z, and F by A force of the liquid per area. That unit area is pressure due to liquid at the bottom. This pressure of the liquid due to pressure of the liquid at the bottom. The pressure due to liquid. So P is equals to pressure at the bottom is equals to H rho Z. And this is the derivation of this formula. P is equals to H rho Z. Thanks for watching my video. If you like my video, kindly like, share and subscribe to my channel. To get all notifications of my channel, please subscribe to my channel and hit the bell icon.